Okay, please make sure that you are aware of induction process before you watch this video, because it's mainly about just the algebra that we're doing with this. All right, so first off, we need to make a conjecture for this one, for a to the n, which means we're going to need to find what a squared equals, we're going to find what a cubed equals, and we might even find what a to the fourth equals, and we'll see, hopefully, that there might be a pattern. We're going to use, I mean, it's pretty easy to do by hand, but let's make sure that we can use our calculator first. Actually, we'll remind you how to do it by hand first. So we've got 1, 5, 0, 1, and if we want to square that, times it by itself, so 1, 5, 0, 1, and we're going to go row by column. Okay, so just to show you, love the color coordinating that we can do, we're going to go for this spot here, we're going to go the first row by the first column. So 1 times 1 is 1, plus 0 times 5, love it, that's just going to be 1. And then for this spot here, again, it's the first row, but this time it's the second column. So it's going to be row, but by second column. So 1 times 0 is 0, and then we're going to say this 0 times 1, which is 0. And now let's choose a different color, orange. Okay, row, so second row, but now by first column. So it's going to be 5 times 1 plus 1 times 5, and we get 10. And last but not least, we get our second row by our second column. 5 times 0 is 0, and 1 times 1 is 1. Now we can check that on technology. We go math, we're going to go matrix, it's a 2 by 2, and I should know what they are, 1, 0, 5, 1. So we're going to pop in 1, 0, 5, 1, and let's square that. 1, 0, 10, 1. Fantastic. Okay, so now we can go back up, and instead of squaring, let's cube that. Sorry, my pen is not wanting to work here. Okay, so 1, 0, 15, 1. And back we go up, and we'll change that to a 4, 1, 0, 20. Oops. 1. So I hope you are as confident as I that we can look at this and we can say that therefore if A equals 1, oh, I don't know why it keeps fading, 1, 0, 5, 1, then A to the n will be 1, 0, right? What's the pattern here? When n is 3, this was 15, when n was 4, this was 20, and of course when n is 2, this was 10, so do we agree this will be 5 times n? Okay, and that's 1. And we better put that n has to be positive integers, because that's one of the issues that we have with matrices. All right. So let's get into our proof now. Now, P of 1, right, equals 1, 0, I'm going to say 5 times 1, 1, which equals 1, 0, 5, 1. Okay, and that equals A. So therefore P1 is true. Now we are going to assume, just like we've done with all the other induction, we are going to assume pk is true. So what does that mean? That means that a to the k, we are going to assume that that is going to be 1, 0, 5k, and 1. And we wish to prove pk plus 1. So we wish to prove that p k plus 1, right, equals 1, 0, 5k plus 1. This one, right. Okay, so sorry, just had to rewrite that one. We wanted to see that a to the k plus 1 equals that. Okay, so let's have a look at our proof. So we've got a to the k plus 1 equals a to the k times a, and so this is 1, 5k, 0, 1, and we're multiplying that by 1, 0, 5, 1. So you need to show your multiplication steps. So I guess it's important that we remembered how to times that. So it's 1 times 5 plus 0 times 5. And then we've got 1 times 0 plus 0 times 1. And then we've got 5k plus 1 times 5, which is 5, plus 5k times 0. Plus 1 times 1. And I guess technically this is using our a to the k. All right, tidy up. So this becomes 1, this becomes 5, k plus 1. 1 times 0 plus 0 times 1 is 0, and that is indeed 1. And therefore, pk plus 1 is true. Okay, and of course write your statement, and that's Matrices 1 done.